Okay, so let's go over a couple examples from your book. So first of all, let me zoom in here just so I might as well just do it right here. So if we look at 4, right, this is just 4 times 4 times 4, right? So that means there are 3 4s to the first power, right? So 1 plus 1 plus 1, this is 4 to the third power, right? This means that there are 3 4s being multiplied in a row. Okay. All right. So if we look at number 11, right, we're going to have power of power. So we're looking at 2 times 2 times 2 times 2 times 2. Right? So if we group those together, so we have right here, we have 2 2s, right? So that's 2 to the second power. Pick black, right? And then we're multiplying that. And then we have 3 more 2s being multiplied together. So 2 to the third power. And really, if we count them up, we have 1, 2, 3, 4, 5. We have 5 2s multiplied together. The other thing we could do is we could look at these. So sometimes you'll see me put like a little bean around them and a plus to remind myself that if I'm multiplying and they're the same base, I'm just going to add my exponent. So 2 plus 3, so this is 2 to the 5th power. Okay. All right. And then, so I'm trying to block out some of these other problems because we haven't gotten to some parts yet. There we go. There we go. Miss Mills. All right. So what about number 14? All right. So if we look at number 14, right, then what we have is 5 to the 10th power times 5 to the, now there's nothing there, right? Well, if there's nothing there, that doesn't mean it's to the 0 power. 5 to the 0 power would be 1. This is still 5. So this is 5 to the first power times another 5, right? So that means there's an invisible 1. So we're going to make it visible. All right. So now we have 5 to the 10th times 5 to the first times 5 to the first. So first of all, we know they have the same base, and this is kind of key, right? So they had the same base of 5. So our base is 5. But then, right, we know I could write it out like this. I could, if I wanted to, I could take this 5 right here and write this out as 5 times 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 5. 1, 2, 3, 4, 5, 6, 7, 8 times 5 times 5. And then write these other two 5s down here times 5 times 5. I could write it all out like that and then count them up. But I think there's a chance I might not write the right number, right? You saw me have to go back and count. Plus, right, when I do count them, maybe I'll count them wrong, right? I wouldn't count one at a time anyway. So if there's a big group of things, like let's say I have some bunch of pennies I need to count, I don't count them one at a time. I put them in piles of 5 and count by 5s. So counting one at a time is a good way to mess things up. So what I do instead is I think to myself, well, I'm just going to add all these because I'm less likely to mess up. 10 plus 1 is 11 plus 1 is 12. This is 5 to the 12th power. All right, so I'm going to give you a second. I want you to think to yourself, right? This is the base. That's the boxes to me are a little confusing the way they have it written out, right? But this box is the base, and this box that's up here in the corner is the exponent. So think to yourself, what should go in those two boxes? All right, so hopefully we thought to ourselves, well, we know it should have the same base. The base stays the same. It's just a bunch of 7s being multiplied in a row. So our base is 7, right? But this is 8 7s multiplied in a row and 5. So again, you're going to see me, I'll kind of make like a little bean like this. I'm going to add those two exponents together. So 8 plus 5, right? Well, 8 plus 2 is 10. That leaves 3 more. So this is 13.